Hi there, and welcome to this video on collecting like terms. Algebraic expressions can be collected together if they have like terms. This can be done by adding and subtracting. So for example, in this expression, we have some a's here, and we also have some a's here. Because they are like terms, because they have the same letter, they can be collected together and represented as one term. So this is a way of simplifying expressions. Let's have a go at how we can approach this simplifying question. This is how I often explain my working out. I look at the like terms and the terms that are similar, for example, the a's, I'm going to highlight them in a certain color, or I'm going to draw a box around them. The reason that the boxes and these circles are helpful is because you'll notice they include the sign in front of the term. So this plus, this positive sign in front of the 2a is included within the 2a box. So this becomes quite important when we look at harder simplifying, which includes negatives in further examples. So once you set up the question like this, it's quite straightforward to collect the like terms, to collect the similar terms. If we look at the green boxes, we have 4 a's, then I'm going to add on 2 a's, meaning I have 6 a's altogether. And then completely separately, I'm going to look at the b's. I start with positive 3 b's, and then I'm going to add on 1 extra b. That's going to leave me with 4 b's. Little reminder that when there's not a number in front of a letter in algebra, we always assume that it is 1. So when I simplify this expression, it now looks like this: 6a plus 4b. I've collected the like terms together. I've collected the a's and I've collected the b's. At this stage, I do not make this 10ab or 10a or 10b, even though you can see a 6 and a 4 with an add sign in between. Because the letters are different, in algebra, we have to treat them totally separately, so we do not put them together. This is our final answer. We cannot mix and match different letters, so we keep it separate, and our final expression is 6a plus 4b. Here's another example for me to work through. So this time you'll notice I have a minus 2a here. I'm subtracting 2 a's. When I come to collect the like terms, and I add on my boxes or my highlights or my circles, the fact that this box goes around the minus sign just keeps me right. It means I'm less likely to make an error when I'm simplifying this expression. Because now if I look at the green boxes, I've got 5 a's, take away 2 a's. So I know that's going to leave me with 3 a's. Then if I look at the red circles, I've got positive 3b, and I'm going to add on 6b. It's going to take me to 9 b's. So my final answer looks like this. So again, I do not put these together to end up with 12ab. Because I'm dealing with separate letters, I keep the a's and the b's separate. But the fact that I put this box around the minus 2a just kept me right with my negatives and which terms should be subtracted and which terms should be added. So I really emphasize that you should try, at least when you're first learning this topic, to be highlighting the similar terms, highlighting the like terms in order to get your negatives and your positives correct. Here's another example: 3y minus 4z plus 2z plus y. So again, I'm going to highlight the similar terms. There we go. So this time, even though we're in a different order, the method's exactly the same. I've put a green box around my y's to be left with 3y plus 1y. That's going to give me 4y's. And for my z's, I've put a red circle around my z's. And again, this is helpful because it's showing me that I'm starting on negative 4z. I'm already on my negative numbers. I'm already into my negative numbers. Then I'm going to add on 2z's, which is going to bring me 2 closer to 0. So when I have minus 4z, add a 2z, that actually simplifies to minus 2z. Because I started on minus 4 and I came 2 closer to 0. My final answer looks like this, 4y minus 2z. And again, the red circles around the z's were very helpful in reminding me that I started on a negative 4. Okay, here's my next example. I've used this example just to show you that when we have a's and a squareds, we treat them like totally separate terms. They are as different as a's and b's. They are as different as x's and y's. So if I wanted to collect the like terms in this expression, I'm going to put my a's together. And then separately, I'm going to put my a squareds together. So when I'm highlighting or boxing or circling, it's going to look like this. I've put a green box around my a's. So I've got 4a, take away 5a. That's going to leave me on minus 1a, which I could just write as minus a. And then I've also circled my a squareds. I start on plus 3a squared and then I add on one more a squared, taking me to 4a squared. So my final answer looks like this, minus a plus 4a squared. And that's the correct answer. Don't be tempted to simplify this further or put the a's and the a squareds together, because even though both terms include the letter a, the fact that this a is squared means we're dealing with separate terms completely. So the same method is applied. Okay, another example from me. If you want to go ahead and have a go at this question yourself, please do so. So we've got minus 3c minus 5b plus 5c minus 5b. So again, I'm going to box and circle my like terms. So then if I look at my green boxes, I'm dealing with minus 3c's, and then I'm going to add on 5c's. So I start on my negative numbers, I start on minus 3, and I add on 5. So that's going to bring me over 0 into my positive numbers and land me on plus 2c. Then if I look at my b's, I'm already starting on minus 5b, and then I take away another 5. So I start on negative 5, and then I get even more negative. So minus 5, take away a 5 is going to land me on minus 10b. So my final answer, when I simplify this expression, is 2c minus 10b. So you can see, look, as the complexity of the question increases and there's more negatives involved, boxing or circling or highlighting your similar terms is going to become even more useful. Last example from me before I give you a few questions and tasks to have a go at. So this time I've got 4a minus 9a plus a minus 5m. When I go to highlight or circle or box my like terms, this time you'll notice 3 of my terms contain an a and only 1 of them contains an m. And that's fine. We just treat it the same. So I circle with red my A's. So I've got 4 A's minus 9 A's, then plus 1 A. So that is going to take me to negative 4A. Because 4 minus 9 would be negative 5, but then I'm going to add 1 on to come 1 closer to 0. It's going to be negative 4. My minus 5m, I'm starting on minus 5, and I'm not doing anything to the m. I'm not adding anything. I'm not subtracting anything. So that's just going to remain as it is. So if I go ahead and simplify this expression, I'm left with minus 4a. And I get that from simplifying the red circles, and minus 5m, that's because nothing happens to the green box. And this is my simplified expression after I've collected the like terms. Okay, so here's a task for you to have a go at. On the left-hand side of the screen, I've displayed 6 expressions. They all contain A's and B's, but they are not simplified. So for each of those expressions, I'd like you to go ahead and collect the like terms, watching out for those positives and negatives. They should match up to the answers on this side of the screen. So once they've been simplified, you should be able to match these expressions with these expressions. However, one of the expressions on the left-hand side does not match over here. So there is an odd one out. So your task is to match up the 5 that correctly match up, but also highlight the odd one out that does not match up. Okay, could you pause the video at this point and have a go at this task? Welcome back to the video. I'll just go ahead and show you my solution. My answer looks like this. So you can see the expression that does not match up. This would be your odd one out, and I've highlighted your odd one out over here. If I had 4 A's and I did nothing else to those 4 A's, I'd still be left with 4A, which is correct down here as well. But we're going to have a difference with the B term. Plus 3 B's, take away 2 B's would leave me on 1B. But then I'm taking away another 2 B's, which takes me into my negative numbers and lands me on minus 1B, which we can write as minus B. So the fact that there was a plus sign here is what made this the odd one out. Very well done if you were able to match up the other 5 correctly. Okay, so your next task is a collecting terms pyramid. So this will really test your understanding of collecting like terms and simplifying expressions. What you need to do here is you need to add the terms in any 2 adjacent bricks in order to find the total of the brick above. So for example, you would add 3y to 2y to find the answer of this brick. 2y, add 3z, when we add them together, different letters, so we can't put them together, but we can write them as the expression 2y plus 3z. 3z is going to be added to the adjacent brick here. So 3z add negative 2z would just be 1z. So your task is to use that information and to continue and complete the pyramid by always adding the adjacent bricks together to create the total for the brick above. Okay, if you could pause the video at this point and complete the collecting terms pyramid. Okay, welcome back to the video. I'll just go ahead and display my solutions to this pyramid. It looks like this. So if I just quickly talk through, 3y add 2y gives me 5y. And then this brick is going to be added to this brick. So 3y so 5y, add 2y, add 3z. That's going to give me 7y's plus a 3z, which is what's in this brick here. When I take this brick and add it to this brick, I'm left with 2y plus 3z plus z. So my z's can be put together to create 4z. This is my simplified expression. And then for my last two boxes here, 7y added to this 2y gives me the 9y, and 3z added to this 4z gives me the 7z. Very well done if you were able to achieve the top brick here. Here is another collecting terms pyramid. Slightly trickier this time because I've included a couple of negative numbers. Okay, if you could pause the video at this point and again complete the pyramid. Okay, welcome back. I'll just go ahead and show you my completed pyramid. It looks like this. So first of all, we were missing a brick down here, but we know that this brick and this brick have to add together to give us 7a plus 3. So therefore I knew I needed one extra a, and I also needed the number 2, because when it added to the 1, it was going to give me this 3. Then we can work through the other bricks by collecting the like terms, putting the a's together, and also the normal numbers would be kept separate. They are not like terms to the a, so they would be kept separate. Very well done if you achieve the top brick of 21a plus 9. Here's the final task of the video. I'd like you to again complete this collecting terms pyramid. Pause the video now and have a go at this question. Okay, welcome back to the video. I'll just go ahead and show you my completed pyramid. Looks like so. So again, by adding together the adjacent bricks and collecting the like terms, you should have been able to progress up the pyramid to achieve the top brick of 8a minus 16b. Very well done if you were able to complete that pyramid. That shows a very good understanding of collecting like terms.